All right, good afternoon, everybody. My name is Dave Stauffacher, and you are in the right place if you came to learn about the AWS Storage Catalog this afternoon. And if my clicker would work. All right. Spacebar is, if anything would work. There we go. Okay, so this afternoon what we're going to cover are the building blocks of the AWS Storage Service Catalog and some of the outlying compatible services that help enhance kind of what I call the core three. So the core three are S3, EBS, and EFS. And then the supporting services we'll get into Storage Gateway, Snowball, Data Sync, AWS Backup. I'll talk a little bit about Glacier as well. We'll also go through some of the use cases and best practices, and I'll be happy to share some of the lessons that I've learned in migrating hundreds of terabytes worth of data from our data center out to Amazon. All right, a little bit about me. I have been at Direct Supply for 18 years. Direct Supply is a company that does e-commerce and purchasing solutions for the long-term care industry. So if you think about like nursing homes, we do a lot of services and products for that space. The last 16 years of my career, I've been focusing on data storage and data protection. 2.5 years ago, I was tapped to join the cloud team, or actually help start the cloud team. And so since about late 2016, I've been working exclusively on cloud stuff. Kind of tying back to the keynote this morning, if you guys were there for that, there was a conversation or a few comments about reaching out and talking to the person next to you on an airplane, or putting your comments out there and just getting to know people and having conversations with people. Something similar happened to me, and that led to me making friends with a lot of the storage team developers at Amazon. And so for the last year and a half, I've been working directly with their storage teams on the side to help them set their product roadmaps and design some of their storage products. I've actually gone out and spent a couple of days in their office on 2 separate occasions working on road mapping stuff and kind of helping them shape some of the products that they're bringing to market. I've also done some presentations. I was at Community Day last year, so I did an unconference presentation on cloud automation. And then I've done storage presentations at AWS Summit and at AWS reInvent last year. All right, so who here has a data center background? Like infrastructure, hardware people? Cool, all right. Hopefully most of you, because this is a cloud conference, know the values of cloud storage, but if you're not intimately familiar with the economics of a data center, there are a few things that cloud storage brings to the table that are kind of game changers for people who are traditionally infrastructure focused. So the first is the low barrier to entry. I can buy as little as 1 gigabyte of storage from Amazon and pay 10 cents a month for it, and that's great. In my data center, there is a 6-figure spend to even get into the game of having enterprise class storage. So our product cycles were hundreds of thousands of dollars of investment each time we had to do a tech refresh, each time we had to buy more storage. So the incremental cost to expand, nobody wants to be the project that needs 2 gigabytes more than you have available on the array, because then you're the project that gets blamed for the $500,000 spend that has to happen, right? So cloud storage, you buy what you need, you pay for what you use, it is consumption based. You don't have to predict today what you're going to need 5 years from now and buy that today to make the investment life cycle work and make the finances work. The other thing, too, is that Amazon is evolving their product stack a lot faster than I could afford to recycle and lifecycle my technology stack. So in a lot of cases, like in their EC2 platform, it was a matter of rebooting an instance to change out the instance type. In the storage space, it's a matter of just growing a volume. In some cases, it's happened in the last year, their storage prices actually come down and their storage throughput and I/O capabilities go up. And I've never had a storage vendor call me up, take me out to lunch and say, we're going to give you half your money back, because we've figured out how to do storage cheaper. So the consumption-based model and their product evolution really help to save you money in the long term and give you better technology overall. All right, this is a slide that I put in here because I've given this talk a few times to other less cloud technical groups. Is there anybody here that does not know AWS regions, availability zones, VPCs, subnets? I'll be happy to go through it, but I'll just skip over it if you guys, are we all good with that in the room? All right, I see a lot of heads nodding. We're going to skip over it. If you want to know more about it, come see me after. I'm happy to talk. All right, so the first service we're going to jump into is Amazon S3. And Amazon S3 is their object storage platform. So that means that all files are addressed individually. Instead of having just a file system where you can browse up and down the folders, each file is looked up individually. All the access to those files is through HTTPS GET and PUT requests. So it's all API driven. You can open up their web console and poke around in it and see your files there, and you can download or open the files, but it's not like Windows Explorer where you can just browse the file system through a nice little GUI interface. The other thing is you'll need separate tooling, and we'll get into that a little bit, if you want to use S3 storage and have it behave like NFS or SMB storage. Now, Amazon S3 is eventually consistent. So what that means is that when your data gets written to S3 the first time, it's available immediately, but any updates you make to your data or any deletes of, deleting your data, that is what's called eventually consistent. So if you have multiple clients reading and accessing the same data in your S3 bucket, if you delete an object, the other hosts might still see that object for a period of time. So just something to keep in mind, because you can get burned by that if you're like trying to run a web farm and have all your nodes access the same data at the same time. All right, encryption is available for S3. It's a feature you can turn on when you provision your S3 bucket. If you turn it on after the fact, it does not recursively go back and encrypt the data that was there before you turned on encryption. So we have a practice in our org when we spin up an S3 bucket, we do everything as infrastructure as code, and our code is pre-configured so that it automatically turns on encryption right from day one. That way we don't end up with any accidentally unencrypted data. All right, access control. There are three primary methods for accessing the data that's in your bucket. There are bucket policies, access control lists, and IAM policies. So bucket policies are something that you would configure on each individual S3 bucket to grant access to other assets. We use it specifically for separate accounts. I wouldn't really use a bucket policy in many other use cases, but if you need to delegate access to your bucket to specific other accounts, bucket policies are the way to go. Access control lists can control access to individual objects and can grant those to users within your cloud org. The best path, though, that we've used for securing things is to use IAM policies. So we can create very specific policies in IAM that tie users or applications to specific buckets or specific data within a bucket. And that works really well to secure the data for us. All right, now, retention, version management, and replication are all features that are tied to an S3 bucket. And kind of piggyboarding off of the last talk that was in here, if you were here for Mike's talk on cost control, retention and version management and replication are very great features that can be very, very expensive if you use them incorrectly. So let me just give you a little story. Well, let me define these first. So retention is just how long do you want data to stay in your bucket. You can delete it manually yourself. You can have the bucket clean up objects after a certain amount of time. So imagine you've got a backup environment. You want to keep your backups. You write them to S3. You want to keep them for 2 months. You can set a retention policy that then deletes those objects that are older than 2 months. Now you can replicate those objects to another bucket in the same account, different region, same account, same region, different account, same region. And that replication is very easy to configure. It does require that you turn on versioning. So what versioning is is every time you change an object, it saves the previous version of that object entirely. So you can go back and see every incremental save or change to an object. So here's where this gets expensive. We had this backup target that we were writing our backups to. We were replicating that bucket to another account in another region. We were using SQL to write its own dumps to that bucket, and SQL can be very chatty. So what was happening is, at the end of the backup cycle, SQL takes a guess at how big that backup file should be when it starts writing. And then as it gets to the end of the backup, it starts saving and reopening that file. So with versioning turned on, that creates multiple versions of the same object in your S3 bucket, and it replicates those. So what we were expecting to be about 10 terabytes a week writing to S3 was more on the order of 300 terabytes a week writing to S3, replicating to a second location. So you have to be very careful of that chatty app. Now, our fix for that was we just set an aggressive retention time and cleanup on those previous versions. So we accepted the fact that we would have several previous versions of our backup files when they're written, and then we purge those almost instantly. So they're created, but long-term, we're not storing them indefinitely. Now, a couple other things that'll drive your cost and your management in S3 too is there are different tiers. So S3 IA is infrequently accessed. So if you put data into this tier, you save about 50% on the cost to store the data, but you pay when you retrieve the data. Now the problem is if you put your data into IA and then you access it before it's been there at least 30 days, they charge you the full 30 days to store it in IA, plus they charge you the retrieval fee on top of that. So in our backup case, we were further compounding our cost problem by the DR copy being in infrequent access. So it was replicating 14 versions of each file, and each version of that file was getting hit with the 30 days of IA fees on top of the early retrieval fees, and every time it changed, we got dinged with an additional fee. So be very careful. I will say we caught this very quickly. So this was only rolling for about a week before we shut it down, figured out the problem, figured out how to work around it and get it back under control. But let's say it's the end of the year when you turn this on and then everybody's on like a holiday break. Then you come back and you're just not noticing it. You're kind of still in that post-holiday brain mind. And then your cost guy comes by a month later with this report that's just got big spikes on it, and that gets expensive. So be careful with IA. Now, IA single zone, S3 is a regional service, so it spans all the AZs in a region. IA single zone is in just one availability zone only. So if you lose that availability zone, your data's gone. Just use IA would be my recommendation. Glacier is a tier below IA, so Glacier is super cheap to store your data, sort of. But then again, you pay on the retrieval of that data as well. The thing to note is that when you store an object in Glacier, they tack on almost 40 kilobytes of metadata to make it faster on the retrieval for them. So if you're putting small objects into Glacier, if you're saving 50% to put your object into Glacier, you're still tacking on additional capacity. So if you have a lot of small objects, it can end up costing you more than just storing it in regular S3. So I would advise you to read the documentation on S3, get very familiar with the cost models. There are a lot of great ways to save money, but there are a lot of gotchas as well in using S3. Now they've tried to help with some of that by releasing what they call intelligent tiering. So this is a relatively new feature. It was released at reInvent last year. And the idea is that they apply a little bit of compute along with your S3 to monitor your data access patterns, and then they manage moving your data to colder tiers to save you money on the storage costs. Great in concept. I love what they're trying to do. One thing to be careful of is if you're going to change the way you're using your data, or if your data is available to a lot of different development groups that may decide in the middle of the night that, hey, we should start querying this other pile of data to see what value it has, that can result in all of your data being pulled back up to standard S3 or getting early retrieval costs if it's been tiered down. So something to consider there. All right, so the second of the kind of core 3 services is EBS, and this is their elastic block storage. So if you're a SAN guy, this is SAN storage. They have a few different tiers. So there's GP2, which is just your standard solid state disk. It scales in performance as it scales in size. So 3 IOPS, or 3 I/O operations for every gigabyte, up to a maximum of 16,000 IOPS per volume. And your throughput is capped at 250 megabytes per second. Volumes for standard GP2 storage can go up to 16 terabytes. There's an IO2 version of storage, which is a provisioned IOPS, so you can tell them how fast and how many I/O operations you need that storage to be able to support. And that can go as high as 32,000 IOPS in this storage. And your throughput is 1,000 megabytes per second. ST1 and SC1 are spinning disk technologies. They have a 500 gigabyte minimum volume size. And they're capped at either 500 megabytes or 250 megabytes, respectively. Now, the spinning disk they offer is really used for streaming workloads. So if you're not doing streaming, if you're doing a lot of like log, in and out kind of I/O, use the solid state versions of EBS. Now, EBS has a concept of burst credits. So the idea is that they set a threshold for how much they expect you're going to use your volume. And if your usage is below that line, you're earning burst credits. If your usage goes above that line, you're burning burst credits. So it's a little bit of an eye chart, but kind of at oh no, it's on the next slide. We'll have the burst credit one. But there are burst credits for each volume. You start with like enough to go to burst to maximum I/O for 30 minutes, I believe, when you create a volume. But you need to watch those. So if you provision a volume and you're hitting it really hard and all of a sudden your performance just drops off, start looking at your burst credit balances. Because it may be time to upgrade from a standard GP2 volume up to an I/O provision volume if you need that higher throughput. You can also present multiple volumes to a host, and you can RAID those on the host. So that's another trick you can use to get higher throughput and performance out of your storage if you need more than what they're offering in their standard volumes here. All right, figuring out where I was at in my slide here. All right, so performance planning, there's another piece of it, not just the type of volume and the size of the volume. You also need to understand what your host is doing and what your host capabilities are. So one of the lessons that we learned, and this is kind of in parallel with what was going on in our S3 bucket, is we were using a file gateway running on an instance that was sized appropriately from a CPU and memory standpoint, but the instance has a maximum throughput cap to its EBS volumes. So we were running an instance, and you can kind of see this comparison chart between the instance types. We were running an R4 large, and the EBS bandwidth here is 425 megabytes per second, and the throughput is 53 megabytes a second. Well, we were hitting it with a lot more than that, so we were bumping up against that cap. When we replaced the instance size with a 2XL, we got it up to 1,700 megabits per second maximum bandwidth, and the throughput was 2 gigabytes rather per second. So you can run into situations where your instance is not provisioned large enough to handle the kind of storage throughput that you need. So another lesson is, this is from a site called ec2instances.info. It's great because you can search and compare different instance sizes on a lot of different parameters. So they'll do cost, they'll do memory, CPU, network, throughput, all of that. So that's a good resource to use to help kind of figure out. And you can use that too if you're worried about the cost of your EC2 instances to find similarly configured instances with similar behaviors that cost less to operate. All right. Other things about EBS storage is EBS is tied to a single AZ. So you can present the storage only to hosts in that AZ, and it can only be presented to a single host in that AZ. So if you're trying to architect something where you have like shared disk between multiple hosts, EBS is not for you. And if you're looking for services that are going to spawn in multiple AZs, or could die and respawn in a different AZ, you need to make sure you take into account that the EBS storage needs to be able to move to a different AZ. And the method for doing that is to snapshot it and create a new volume from that final snapshot. And you can tell the volume to come up in whichever AZ you want. All right, the other thing is with the snapshots, they just released a new feature. Up until a couple of weeks ago, you could only snapshot volumes as individuals. Now you can create consistency groups and snapshot crash consistently across multiple EBS volumes on the same host. So if you have a SQL Server with multiple volumes you want to snapshot all at the same time, you can get them consistent across all the volumes now. So that's a new feature literally within the last like 2 or 3 weeks. All right, the third of the kind of core services is EFS. It stands for Elastic File System or Elastic File Service. This is NFS-based storage only, so you can only attach Linux systems to it. If you have a Windows system with the NFS client on it, it still will not attach. So, and I've tried everything I can think of to make this work, to be able to attach it as NFS and then represent it out as SMB. Because the neat thing about EFS is it's multi-AZ capable. So you create a volume, you can attach hosts in multiple AZs to the same volume. But it is NFS only. They figured out all the tricks that people like me would try to do to get it to work for something it's not intended to be. And they do a good job at blocking you from being able to do that. Now, the cool thing about EFS is you can extend it into your own data center. So if you need some file storage for Linux servers in your own data center, you can provision EFS. And if you get all the routing correct, you can actually attach your own on-prem hosts to that. Now, things like your connection out to AWS will factor into the performance, but it is possible to do that. All right, because it's Linux only, it's POSIX permissions only, so there are no like Windows ACLs or Active Directory integrations or anything like that with it. It does support encryption at rest and in transit. The encryption at rest is at the volume level. The encryption in transit is at the protocol level. They support NFS 4 and 4.1, but not fully. So they don't have the directory and LDAP integration turned on. But the rest of the services they do have turned on for like the TLS. All right, so much like EBS, EFS has a few different performance tiers. So their standard performance is 7,000 IO maximum per volume. And they have a max IO version that is 14,000 IOPS per volume. But your individual file operations are a little bit slower. So use the maximum IO for, again, if you're streaming data into your EFS volume. Individual, like home folders and stuff, I wouldn't worry about the max IO stuff. All right, they've also released a lifecycle management capability, and this is new. I think it's something like the last month or so. But what they're doing with the lifecycle management is files that you haven't accessed in 30 days automatically get tiered down to an infrequent access. Much like S3, you're saving money on the cost to store it, but you're paying to retrieve it. So you can turn this on. It does automate it, but there are big warnings on their documentation that, you know, if you go looking through your old data, you're going to get charged for the retrieval fees. All right. A couple other things to note about EFS is that there are no snapshot capabilities. So if you need to back it up, you can either use the AWS Backup solution that they've released in the last 3 months, or you can use a CloudFormation template to create an EFS to EFS backup. So you create a second EFS volume, and then you would use their tooling to copy the data from source to destination. I have one other point here. Yeah. I'll think of it all. Oh, yeah. The difference, too, with EBS, you're paying for what you've provisioned. So if you provision a 1 terabyte volume, you're paying for the terabyte, even if you only put a few files out there. EFS is different. You're paying for what you consume. So you can tell it you're going to need a whole bunch of storage, but you're really only paying for what you're actually storing on your EFS volume. Now, EFS does cost 3 times what EBS costs. So if the idea is I need a data volume and I want to just create one, and then I'll attach each of my hosts and they'll have their own directory on it and source their own data from that, you're paying too much for your storage because it's 30 cents a gig versus 10. So unless you have a use case where you need multiple hosts in multiple AZs connecting to the same data and using that, you're better off using EBS presented to local hosts, unless you need to keep data consistent across multiple hosts or whatever. But our use case for this at Direct Supply is that we actually presented, if you saw in the lightning talks this morning, we were talking about the solar cloud implementation. That was one of my teammates giving the talk. And what we did was we used EFS at the core. We presented an EFS volume out to all of our ECS container hosts. And then we put the data that we need to bootstrap some of the containers right on that EFS volume. So wherever a container comes up, that volume exists as a mount point on the host and is exposed into the container. So for that, we're using very little storage, so it's not costing us a lot, and we can put a lot of containers into that same, accessing that same data source at the same time, and it works out well. At the bottom here, they also have the same burst credit system as the EBS volumes. And so you can see here, depending on the size of your file system, determines how many burst credits you earn in a day. So if you've got a 4 terabyte or larger volume and you're doing less than 200 megabytes per second as your average throughput, you could burst for 50% of your day. So 12 hours a day you can burst. So rather than using your high I/O, you can get by with just their GP2 tier of storage. And if you've got, work hours, 9 to 5 kind of heavy traffic, and then it dies down at night, you don't have to pay for enhanced I/O. You'll have the burst credits to cover it. All right, Amazon FSx is one of those kind of outer ring services. This is a new thing. It's a fully managed file system, and there are 2 flavors, Windows and Lustre. How many of you are from Windows shops? Okay. How would you rate on a scale of 1 to 5 your Windows file server experience in Amazon? 0. 1? All right. So FSx is their first shot at making Windows customers feel like they don't have to flee to Azure to store files. And we'll cover Lustre a little bit here. Lustre is a massively scalable open source file system that is designed for massive throughput. I think in my notes here, it's like hundreds of thousands of IOPS. If you scale it out and stripe it across multiple, you create their highly available solution. Lustre is used for a lot of intensive data analytics workloads. My interest in FSx is from a Windows standpoint. I come from a Windows shop, and we have 80 terabytes of Windows file data. And there's not a great native solution until FSx came along. So under the hood, FSx is running on Windows servers with EBS storage backing them, and they've figured out a way to replicate that around in a single AZ. But as of right now, it's a single AZ only solution. So if you need multi-AZ, highly available Windows file storage, you still have to think about building a DFS, distributed file system, and managing that yourself, and you can attach that to multiple FSx instances. So I would stay tuned on that one, because I know from talking with the folks at Amazon that the number one request they're getting from their customers is for that high availability solution. Why use a managed file system if you then have to go back and architect your own DFS environment to maintain? They realize that, but it's we have to crawl before we can walk, before we can run sort of a situation. But from a Windows standpoint, it works great. It's very easy to provision. You can plug it into DNS, you can join it to AD, and it handles all of the standard Windows access protocols, ACLs, etc. So very easy to use, very familiar if you're a Windows file shop, and it works great. All right, next are the gateway services. So they have 3 of these. There's a volume gateway, a file gateway, and a tape gateway. So we'll start with tape. That's the easiest one. It's a virtual tape library running on an appliance backed by S3. So your backup environment writes to it like tape. It then sends that data to S3 and stores them as tape objects. So all of your data is compressed into a tape object. It lives in S3. It can run on EC2, or it can run on an OVA in your VMware environment on-prem. Or they have a new appliance you can buy and install right in your physical appliance to install in your data center that you can use for that. The volume gateway, same idea. If you need to add SAN storage into your data center, but you don't want to buy another big frame, you can run a volume gateway. Now the challenge is there's two flavors of volume gateway. One where it just caches the most used data and then pulls everything else from S3. And the other version where you've got the entirety of your data living on those local cache volumes and replicating to S3. So you're going to need storage to host that cache. So if you're doing more than just the cached volume version, you're going to be burning as much SanDisk on-prem as you are replicating out to S3. So just something to keep in mind with that one. Their physical appliance that you can buy comes with 5 terabytes of cached disk built into it. So that might be an option if you just need a little bit of storage, but you want to keep all of that data on-prem. You can provision up to 5 terabytes of it as a volume gateway. All right, the third flavor is the file gateway. And the file gateway is essentially a NAS front end. So you can launch it in EC2, you can launch it in VMware on-prem. I think they support Hyper-V as well with that one. Again, the idea is it's an appliance, you attach a cache volume to it, and then it writes all of your data back to S3. The first version was NFS only, but it did work with Windows running the NFS client. They then added SMB support, but it was only the POSIX permissions for SMB. And then about a month ago, they added full Windows ACL support. But to turn that on, you have to run some AWS CLI commands to enable that. And all of that's in their documentation, but it's buried kind of deep. So if you have questions about that, feel free to reach out because we've got that running in a few environments now. So this works great as a NAS environment. We are using this actually as a DR copy. We've got a third-party tool that's synchronizing data from our on-prem NAS out to file gateways that are backed by S3. So the data just copies over the network like it's copying to a separate NAS, and then it's living in S3, so we're getting that nice S3 cheap storage cost. Now, a few things to consider is that the gateways are single instances only. They're not highly available. So if you need something that is 24/7, 365, and super fault tolerant, gateway is probably not the right service for you. Unfortunately, again, back to the FSX conversation, there's not really a highly available Windows file solution out there yet, unless you want to go third party. So, but Gateway has been very reliable for us, and in my experience, it's been a good fit. Now, a few things. You can write data directly into S3. So if you have a workflow where you're like in the middle of, say, moving out to the cloud, and you've refactored some apps to be S3 native, you can then refresh the cache on your file gateway, and it will pick up all of those changes in S3 natively, and then make those available through either the NFS or SMB to your file gateway. You can have multiple gateways attached to a single S3 bucket, but you can only have one of them writing to the bucket. So we use this in a situation where we have, we want to back up all of our SQL in production, and then we want that data available to our QA tier so they can restore it to keep QA relatively synchronized with production. So we share the bucket with the QA tier, and then we have a separate gateway in QA that reads from the production bucket and presents that data as read-only. And then we tier that on down as well to our dev tier. So you can have multiple readers. The multiple readers also work well if you are in a situation where you need really high throughput to pull from the bucket. You can add multiple readers for that as well. Multiple AZs, for example, that works well as well. So the use cases here, again, this is what we were using as the target for our SQL Server. So this was fronting our S3 bucket where we had the crazy explosive growth. And the gateway instance was the instance that was having problems talking to its cache volume, and that's where the performance bottleneck bit us. So scaling up our instance type got the cache volume working a lot more efficiently. So the big gotcha is just to make sure you use the right instance type and that the instance type can talk to its own cache volume fast enough for your workload. All right, Snowball services. Snowball is a portable storage device that you can order from Amazon. It will come to you. You plug it in your data center, copy your data onto it, and then send it back to Amazon. They put it into S3. At the surface, it sounds great. They even have an edge version that has some compute in it, so you can load data onto it and run processing against that data, and then capture the output of that processing and send that back to Amazon to load into S3. Great on the surface, but there's a few lessons that I learned in doing this. Number one is that you're paying a flat fee for the box, and you get it for 10 days. After 10 days, it's $20 a day. So if your UPS guy's a little lazy and doesn't feel like picking it up in the afternoon on a Friday, and it sits through the weekend, you're paying for that. So make sure you're cognizant of your timing when you're sending it back. Number two, my expectations were that I would go to the website, you provision the jobs, so you say, I want to copy my data to this specific bucket, so send me a thing. I thought that when I picked the next day shipping, that meant it would ship next day. They take a few days to provision it on their end before it ships. So the front end and back end, you get it for 10 days. It can take them a while too, both on the front and the back end, to move your data, prep the device, and then move your data off. One of the other things I learned is that hardware fails, and even if it's wrapped up in this really like disaster-proof looking box, it can still fail. And so we had a flawed device show up on our data center floor. We loaded all of our data onto it, and it took forever. The problem was it had some failed disks inside the box, and it was just going through and trying to fault correct all of those disk write errors. Our data, thankfully, ended up fully intact out in S3, but it took like 4 times longer than even Amazon estimated it should take. So just beware these devices can fail. So if you copy your data onto it, don't delete your data once it lands on the thing. Delete your data after it's in S3 and you have validated that it's viable data in S3. Let's see, what else was there? The tool that you use to copy data onto here, it's an Amazon proprietary tool that basically uses S3 commands to copy the data onto the device. The problem is it's picky about file naming standards. And so when I pointed it at a 40 terabyte directory and said copy, it ran for 3 days doing its pre-copy check. And then it failed because there was a file that had an extra space after the file name extension. And so it aborted 3 days of pre-flight check. So I fixed that file, and then I reran it, and 3 days later it said there's another file in the same directory with the same problem. So day 9 of my 10 days of having the data, I was finally moving data. Now it moves very fast. You have a lot of different connectivity options, and it did not take long to put 40 terabytes of data onto the device, so I only paid for a couple extra days. I've given them very specific feedback that they need a tool that I can be running to make sure my data is okay before the device shows up, but that does not exist. So read the documentation, maybe write your own little script to find some of those flaws. You can save yourself a lot of time, and time is money. But just beware their copy tool is a little touchy. So, all right, so use cases for this. We use this to migrate 80 terabytes of data into S3, like I was mentioning during the file gateway. We moved the data to S3, and then we put a gateway in front of it and had it read the data into the cache. And now we're synchronizing data through that gateway out to S3 as a DR copy for a bunch of data that has to stay on campus. All right, one of the last services we're going to talk about is Amazon Data Sync. So Data Sync is a relatively new service. Again, this was announced last year at reInvent. Data Sync does a full copy and then incremental forever of your data. Now, the first version, like with everything Amazon, it's Linux NFS focused, does not handle Windows file systems. Again, the number one request I've been told they're getting is for Windows support for this. But right now, because it's NFS only, it only supports S3 and EFS on the back end. So you install a little appliance, virtual appliance into your VMware environment. You present your storage to it as an NFS mount, and then you run the command telling it where to land the data. And so you either give it an S3 path or you give it an EFS mount point. supposedly works fast. We have only done very small data sets with it. This will flow over your direct connect, which is nice, but they say it can saturate up to a 10 gigabit direct connect. So if you are running this, there's a command line switch to throttle it back. Look into that. Make sure you don't have the network people calling you at midnight asking what happened to their pipeline. So I had hoped to use this with Snowball. So we had hoped that after we copied our data out to Amazon on the Snowball, that this could just pick up an incremental sync and keep syncing the data kind of after the fact, because we only have a 1 gigabit pipe out to Amazon. I did not want to flood that gigabit pipe with 80 terabytes. That was not our case. That didn't work, so that's where we shifted to the gateway pattern. So if you want to use data sync, you have to start with data sync. So. All right, AWS Backup. This is a very new service as well within the last 2 months. AWS Backup is if you're running Lambdas already to organize and automate snapshots, or if you're using things like their relational database service that automates the snapshots for you, this may not be of much value. But if you have a lot that you're trying to orchestrate and want to be able to track all those snapshots, AWS Backup does that. And again, this is one of the 2 approved methods for backing up EFS. Essentially, you create backup like service tiers, so like bronze, silver, gold, and then via tagging, resource tagging, you enroll your EC2 instances or volumes into the backup service. And that part is very, very cool. And it does a good job of scheduling those backups and keeping them running. It has dashboarding capability, and this is what it looks like. If I can find my pointer there. So you don't get a lot of detail, and if you expand the backup job details here, it just lists the 9-character Amazon backup job ID number. It doesn't give you a friendly name. So if you want to say, oh, did my SQL Server backup this week? Good luck. It's not quite there yet. They know that, and they're looking for a lot of customer feedback to help them improve and shape what this dashboarding piece of it needs to be. Right now, though, you do pay a per gigabyte charge on top of the footprint of the snapshots that they're producing or the data copies into EFS. So take a look at it, run those cost evaluations before you turn this on. Because if you're relying heavily on the dashboard, you're going to be paying a premium for the dashboard. And because it's very limited right now, you need to make sure you understand what premium you're paying for this the level of feature that you're getting. It's a very new service. I expect a lot of announcements from this at reInvent this year. That's my own speculation. But as it released, it's a very young new service. So, all right, last we'll touch on marketplace apps. We spun up a NetApp filer. This is one of the third-party highly available Windows file systems. And so if you search in the AWS Marketplace, you can find a few different storage vendors that are out there. NetApp is one. There are a couple of others. SoftNAS is one. All of them are designed to work running their software on Amazon resources. So, for example, the NetApp runs on EC2 instances with EBS storage on the back end, and you can integrate some S3 to tier your data down there. But the way the cost models work is that you pay for the AWS resources and you pay a marketplace subscription fee. So if you want to build a 10 terabyte file system, you're still paying for 10 terabytes of EBS disk and the instance to drive it, plus you're giving NetApp a per hour fee for running their software. So again, do your cost analysis before you deploy these, because it can get and did get very expensive. Now, if you have requirements that a marketplace solution will meet that Amazon doesn't, then you may just be stuck doing that for now. But I do know that Amazon is aggressively looking at what people are buying in the marketplace, and they're looking at what the features they're offering to figure out where they need to go with their product offering as well. Monitoring, implementation can be challenging because you can't just go out there and buy it. So if I was buying a new storage array through my normal purchase process, I'd have on-site solutions coming and helping me get that set up. I can just buy a NAS through the marketplace with absolutely no help getting it running, and I'm left up to their documentation. So if the documentation's not great, you're going to find yourself needing a little bit more hand-holding and support. It is available, but it may not be the kind of white glove service you're used to in the data center world. Also with monitoring, specific to the NetApp, the way they run their software obscures the ability to see the normal metrics that you'd look at in CloudWatch, like disk throughput and CPU and memory consumption. So just be aware and read, again, documentation is your friend. Make sure you understand what's going on with the hosts and what they're obscuring from you, and then what tools you have to buy to be able to see that. And then support, be prepared for a lot of finger pointing. So we had an instance where our NetApp was performing poorly and actually crashing. The error said it was a network problem between the host and the disk. So off to Amazon we went, and they came back and said, no, there's no problems. Tell NetApp it's a problem with their software. And NetApp said, well, our software said it's host and disk. You need to call Amazon. And so we got a lot of this until Amazon came back and said, here, NetApp, here's your bug report that we found last week or whatever. So a lot of finger pointing between the two to get to a support resolution. The other piece is that with the cloud products, a lot of times they're just evolutions of the on-prem products that people are familiar with, and they're designed as retention plays. So you've been running NetApp in your data center for the last 5 years. You're moving to the cloud. Hey, we have NetApp in the cloud. Let's build a seamless transition, use NetApp in the cloud. And for that, it probably works well for them. But there are not necessarily the same level of support for the cloud products as there are for the data center products, because the people also have to understand how the underlying cloud stuff works. And so you may find yourself in longer than expected hold times waiting for the cloud guy to become available to take a look at your issue. So just something to note going into it. All right, and that's all I have on the storage catalog. My contact info is up there. I know we're right at time for the session. But I'll be out in the hallway if anybody wants to chat more about the storage. Feel free to find me on Twitter, LinkedIn, email me your questions. I'm happy to talk. Cool. Thanks, everyone.